Okay, so building a practical longevity plan. There's a lot of interesting information out there about what's going on in the longevity and anti-aging space, but what there really isn't yet is any sort of guide to how do I actually get started? If I don't know anything about what's going on in the field of anti-aging and longevity, how do I go from zero to actually having some sort of a plan where I'm doing certain things and I know why I'm doing them in order to try to reverse or at least slow down certain aspects of the aging process, and what is actually possible there and how do I actually get started? That information isn't really out there, so this is essentially my coaching strategy that I'm using with my clients to build a customized plan that works for you. You don't need to take notes during this talk. It's being recorded. I will make the recording available to everybody within the next couple of weeks. You also don't need to take notes. There are links to a lot of fascinating papers, but I've got a Twitter account and a Facebook account for this meetup group. And after the talk, I'm going to be posting links to all those papers so you can dig into any particular areas where you want to know more or find out what the scientific basis is for any of this stuff. And we'll have a Q&A at the end as time permits. I've timed this talk. It comes in right under 90 minutes. I do talk really fast. If I'm going a little too fast, just raise your hand and I'll notice you and I'll try and slow down. I apologize for that, by the way. But again, if there's anything you missed, it will be available. The recording will be available sometime in the next couple weeks. Okay. There we go. Okay, just a couple disclaimers to get started. I'm not a physician. This presentation is for informational and educational purposes only. Everyone is different genetically and otherwise. None of the interventions described in this presentation should be construed as contradicting the advice of your doctor or a recommendation for you specifically. I want to start off with some common questions that I often get when I'm talking about this kind of stuff. What makes you think radical life extension is possible? Notice I said radical life extension. I did not say immortality. There is no way currently to become immortal. We're not even close to that point yet. But what we are at the point that we are at is that we're looking at serious extensions to human lifespan in the very near future. And hopefully by the end of this talk, I'll be able to tell you about a lot of reasons to believe that's the case. We've now extended the lifespan of many animal models by more than 10%, especially mice. We've got several interventions where mice can live 50 to 80% longer. And there's now good reason to believe that that's possible in humans as well, especially with the TRIM trial that I'll talk about at the end. Is anything you discuss here actually proven to extend life in humans? Well, the answer here is sort of, right? If you have an intervention that's going to make people live longer, you can't just give it to grandma. Grandma's 70 years old and say, okay, now let's wait until grandma turns 120 and see if she actually lives that long, because that takes 50 years. So you have to use other means to find out if your interventions are actually working. And we'll talk about some of those. Won't this mean that only rich people can use these regenerative therapies? And the answer is no. There are a handful that are very expensive that are available right now. But at least 90% of what I'm going to talk about this evening is very affordable and very low cost. Some of it's free. And the expensive stuff will be a lot cheaper within the next 15, 20, 25 years. Another question is, when will there be a pill I can take? And of course, the answer is never. Dr. Dale Bredesen has written a book called The End of Alzheimer's. And he has an awesome metaphor for Alzheimer's disease, as well as other forms of cognitive decline. And he describes it as 36 holes in the roof, right? You've got this roof, it's got 36 holes. If you only patch one or two of them, it's not going to make any difference. You have to try to patch all of them. Aging is a very, very similar sort of thing. You have to use many different interventions because there are many different things going on in the aging process. You have to start with diet and fitness and supplementation and basic things like that and build a foundation. Then there are other interventions, holes that we can't quite patch yet, or that are too expensive, but in 15 or 25 years, they will not be nearly as expensive, and they will be much more readily available. And my best advice I can give you is learn everything you can and get started now. Another question people ask is, does the world really need this? And the answer is yes. The boomer generation is getting older. There are going to be 72.1 million people over the age of 65 by the year 2030 in the US alone. That is a tidal wave of people entering the Medicare system, of people retiring. It's going to be very, very difficult to support those older generations, and this is happening in almost every country around the world. It's not just the United States. The silver tsunami. 80% of US healthcare costs are due to age-related diseases or conditions, and that number is going to keep going up over time. People will often say, okay, I don't want to live hooked up to a machine for an extra 10 or 20 years. By the time I'm 80, I'm probably going to be lying in a hospital, going to be hooked up to a machine, artificial pacemaker, and so on. What's the point of extending that? Related to that question is another question. People ask, won't it be just this horrible social crisis where we won't be able to feed everybody, right? People start living a lot longer, there's going to be environmental catastrophe, we won't have any way to pay for all this, we'll have flying monkeys. My answer to both of those questions is the same. Let's talk about health span versus lifespan. Lifespan is when you die, right? The purple bar that you see at the bottom ends at about 90. This is a person who lived to the age of 90 years old, and their quality of life, their health, steadily declined until they got to the age of 90 and died. Health span is the amount of time you spend in a healthy state, right? It's the amount of time you spend physiologically, biologically, as a 20-year-old, 30-year-old, 40-year-old, right? And what we're finding is, in order to seriously extend lifespan, we also have to extend health span, right? It's not one or the other. Radically extending lifespan is not going to happen unless we also radically extend health span. So here's another way of looking at it. You see sort of the progression of life in this image at the bottom. And the point that I'm trying to make is what future regenerative therapies are going to give us, as well as a couple present regenerative therapies, is they're going to extend those middle years of our life when we're in our 20s, 30s, 40s, early 50s, whatever, and we're able to be productive, we're educated, then we'll have a much larger percentage of the population as a skilled workforce able to solve all of the problems that society faces. So to wrap that up, adding more years to your life necessarily implies adding more life to your years. And this necessarily implies an increased percentage of educated, productive citizens that are needed to solve the world's problems, whether it's global warming or anything else. So let's talk about aging versus the diseases of aging. No doubt you've all seen a whack-a-mole at an arcade at some point, right? You've got this little machine, randomly these little moles pop up out of the machine, and then you get a hammer and you whack down the moles one at a time. So that is sort of a good way to think about the diseases of aging. Think about you've got a mole that's named Alzheimer's disease. You've got a mole that's named type 2 diabetes. You've got a mole that's named cancer. You've got a mole for heart disease. Now the way medicine currently attacks the problem is it looks at disease. It does not consider aging itself to be a disease. It considers all of these individual things to be diseases. And so the little mole comes up for Alzheimer's disease, you've got to try and grab a specialized hammer for that particular mole and whack it down. Then the mole pops up for cancer. You've got to grab a completely different mallet for that and whack it down because we have totally different medicines to deal with cancer, right? Same thing with heart disease or whatever else. And all of these diseases become exponentially more likely as we get older, right? Doesn't mean that teenagers don't get cancer, right? Little kids, unfortunately, sadly, get cancer, but the chance of an 80-year-old getting cancer is far higher than a 15-year-old, right? Now, what if there were a way where instead of grabbing these individual mallets for these individual moles, we could just unplug the machine, right? Or what if we could reach into the machine and just find a way to slow it down and stop the moles from coming out so fast? That would be pretty awesome. I went to a conference called RadFest in Las Vegas last year. It was pretty amazing. There were a lot of scientists there, top researchers in the field of anti-aging and longevity. Every single one of them that I spoke with, every single one said within the next 15 to 25 years, we are going to see massive progress on aging itself. Not the diseases of aging, but aging itself. And there are many useful interventions that are available right now that most people don't know about. So, my advice is start preparing now. The earlier the better, because if you wait until you're 75, it gets a lot harder. Here's a really interesting quote. You might have seen this book on the right. This, I believe, was on the New York Times bestseller list. It might still be there. Lifespan, Why We Age and Why We Don't Have to, by Dr. David Sinclair. I love this quote. I believe that aging is a disease. I believe it is treatable. I believe we can treat it within our lifetimes. From the looks of it, aging is not going to be that hard to treat, far easier than curing cancer. And I highly recommend that book, by the way, because he explains exactly why he believes that. And we're going to cover some of that in this talk today. There's a good metaphor for this. Model T Ford, right? Today, in the year 2020, you can drive a Model T Ford, an original Model T Ford. How is that possible? There's only a handful of them in the entire world, but they do exist. So why are these Model T Fords still around when all the other Model T Fords, which I think were invented like 1918, more than a century ago, why are you still able to drive these particular Model T Fords when all the other ones, were gone 70, 80 years ago? And the answer is maintenance. These particular Model T Fords, they were only designed to last maybe 10 or 20 years, if that. But their owners did an incredibly good job of maintaining them, and anytime a part would break, they would take out that part and either fix it, or if they couldn't fix it, they replaced it. So you ask, okay, can we do that in humans? Is it possible? And the thing to remember is, we're actually made of replaceable parts, right? Except for your bones, right, that are big calcium deposits, essentially. Your body is full of cells. Whoops, our bodies are made of a single replaceable part, which is cells. Every single cell in our body at one point or another was an undifferentiated stem cell that then became a heart muscle cell, a red blood cell, a nerve cell, a brain cell, a fat cell, or whatever else, right? And we have the ability right now to draw the stem cells out of your bone marrow. You've got stem cells inside your bone marrow right now. We can freeze them, replicate them, and re-inject them into your body. Of course, that alone is not going to make you live forever, might not even give you radical life extension itself, but it's one of the therapies that's happening right now. There's a ton of exciting progress being made just on that, and we'll talk about that a little later. A little later in this talk, I'm going to talk about SENS and define what that term means, but essentially the concept is frequent damage repair, just like that Model T Ford. You've got the concept of gerontology. The concept of gerontology is, okay, you've got cellular metabolism, and we know that that causes a lot of cell damage. Gerontology says, how can we minimize the damage that cellular metabolism is continuously causing to our bodies? And that doesn't really work very well because there's so many different kinds of damage that you can't really stop them, right? You breathe oxygen. Oxygen itself causes damage. You drink water, that's got deuterium in it. Deuterium causes damage. That's natural. It's always been part of the water ever since humans were evolving, but it causes enormous amounts of damage to our bodies, right? So you can't really do much to stop that. Then there is the geriatrics approach that says, okay, I'm accumulating cell damage, and that leads to various pathologies, as well as various disease, increasing the risk of various diseases like cancer, heart disease, type 2 diabetes, and so on. Can I stop the damage from causing these pathologies? And that doesn't really work either because you can't really stop the damage from accumulating, and once it gets to a certain point, the risk of pathology just becomes unstoppable. The engineering approach, or the SENS approach, is you say, okay, what if on my 50th birthday, I could do a certain set of interventions that would then revert my body back to the state of a 49-year-old, right? Maybe it's a couple pills, maybe I do some workouts at the gym, do some sauna, a whole bunch of different things, but whatever I do, that combination of things is biologically reversing me by 1 year. Then, a year after that, it's my 51st birthday, but now my body is biologically only the body of a 50-year-old. Now I do the same thing again, and now I'm a 49-year-old again, right? So if we could do that, in theory, we would be aging so slowly that we would effectively not be aging at all. And then you have to ask, okay, how do I do that? What are the different types of damage that I'd be repairing, and how do you repair them? There's going to be a whole section on SENS later in this talk where I will go through those. Most of those, there's only time enough for a single slide, but I will also point you to some books for further reading. So this is the basic summary of my approach, right? 5 different approaches to building a longevity plan. Think of this as 5 different lenses for looking at the problem of aging. We're going to go through each of these lenses in turn. Each of these can be a source of different interventions, whether it's different kinds of supplements, changes to your diet, changes to your fitness regimen, specialized peptides, whatever else. Then you take all of the interventions from all 5 of these different approaches and you say, okay, how do I prioritize them? What's going to work for me, right? What do I actually need to be most concerned about? And then use that to build an actual plan for your own longevity. So the 5 of these, starting from the upper right, optimize your health. Use a systems approach to optimize the entire human system, taking your genetics and epigenetics into account. And I'll talk about epigenetics in a second. Second one is minimize your all-cause mortality risk. That is, minimize your chance of dying for any reason. Third one is optimize key biomarkers. There are a ton of different biomarkers available, many of which correlate either with age or with mortality. And understanding those can really help you get control over what's happening in your body. Upper left corner, repair the types of damage that cause aging, also known as SENS. And we'll look at the individual types of aging according to the SENS taxonomy, which most researchers in the longevity space would agree is, probably a really good stab at the actual set of all possible types of damage that can cause aging. And then what can you do right now to try and reverse those? And also what's coming down the pipe in terms of future research. Finally, do what works in experimental models. In many cases, we have experiments that seem to work in humans or near human analogs like mice, rats, monkeys. And then we can look at those and learn from them and say, is this something that might work in humans? Is this something I could potentially learn from or apply to myself in some way? And that's, when I talk about that at the end of the talk, that's going to include the TRIM trial, which is an amazing trial, and demonstrated significant actual age reversal in humans. And that's pretty amazing. Okay, so let's start with the first one, optimize your health. This means before we even get to longevity and anti-aging, let's try and get as healthy as possible. This means optimizing your diet, your supplements, your fitness regimen, your environment, your hormones, your sleep, so much more according to your genetics, your lifestyle, your personal goals, and your epigenetics. Now I have to define the term epigenetics because most people don't know what this is. Normally, we think of our DNA as being static, and pretty much it is, right? You've got your DNA, it's wrapped up into a bunch of different chromosomes, you've got all these different base pairs, you can submit your DNA to 23andMe and Ancestry DNA and actually download a file onto your computer that is your DNA. Here's all your base pairs. It's amazing. You can actually read this thing and it'll be AGCCCTT. And that doesn't change throughout your life. But what's very interesting is your DNA can actually be modified. I shouldn't say modified. Modified isn't quite the right word. It can be decorated over time, right? Your DNA is constantly getting these little methyl groups added and removed, right? Little chemical markers on areas of your DNA called introns. every single thing you do affects the methylation of your DNA and how many methyl molecules are added to which parts of your DNA. Also, your DNA can be wrapped around big blocks called histones. Those are these little pink blobs in the middle, and that can turn off parts of your DNA, expression of parts of your DNA entirely. You can think of epigenetics as the software that's running on top of the hardware of your DNA. Your DNA base pairs do not change throughout your lifetime. You've got some little random mutations, but they really don't matter. They don't really impact you. But what you do have is epigenetics and all these little chemical groups, methyl groups and acetyl groups, getting added to and removed from different parts of your DNA. And everything you do, whether you drink, how much sleep you get at night, whether you're stressed out, your fitness routine, your supplements, how much vitamin D you're getting, whether you drink olive oil, is going to affect your epigenetics. There's a really interesting study that was done. The Dutch famine. In the Second World War, the Nazis got mad at the Dutch. They tried to starve them out. That was called the Dutch famine. One of the really interesting things that happened, horrible but interesting things that happened as a result of the Dutch famine, is that women who were pregnant either during the famine or after the famine, like within a year after the famine, actually passed on different markers to not only their children, but their grandchildren in the epigenome. In other words, their children had different methyl groups because of that famine. And they tended to be shorter, and they had a much harder time losing weight because their epigenetics said, holy cow, mom was in a famine or grandmom was in a famine. This is dangerous. I better be really, really careful. I better not get too tall. I better not lose too much weight because mom was starving at some point in her life and I got the epigenetics for that. So epigenetics is actually super powerful. So optimize your health. You've got sleep, you've got fitness, you've got hormones, environment, diet, stress, supplementation. All those are affected by your genetics and your epigenetic expression. And all of them also, in turn, affect the epigenetic expression of your DNA. So you really have to look at this from a big picture systems approach that takes all of these things into account. Now, there's a lot to cover in this section. This section, of course, could be several talks in and of itself. I can't go into a ton of detail on things like diet, but I do have a couple slides on this because it's important to at least cover it at some level. When we talk about diet, we often talk in terms of macronutrient ratios, right? You've got vegans who are super, super high carb. You've got the Atkins 1.0 people that are like, no, protein is everything. You don't need carbs or fats, right? There are a lot of extremes out there. So you have to ask, is there a macronutrient ratio that is optimal for everybody, right? If you find a diet that works great for you, should you go to your neighbor and say, you should be doing this diet as well? And the answer is no. And just to briefly explain this, here's a triangle. Lower right corner is protein, the top is fats, lower left is carbohydrates. Of course, this is a ridiculous oversimplification. I'm just putting it out there because there's so many different kinds of carbohydrates, simple versus refined carbohydrates. There are many different kinds of fats, monounsaturated, polyunsaturated, trans fats, whatever. Many different amino acids. So it's a huge oversimplification, but just to get this point across, imagine you've got this triangle and you're trying to find a point somewhere on the triangle that is your diet, right? So this would be Atkins 1.0, where we're essentially is eating almost entirely protein only. Lower left corner, carbohydrates, that would be something close to a vegan diet where we're getting almost all carbs, very little protein, very little fat, right? So to show you, so you're trying to figure out what point on this graph should I actually be in. So the low concept of minimizing the amount of fat in your diet was certainly very popular in the last century. But really going too low in fat is a pretty terrible idea for most people. So I want to debunk the notion that you should be anywhere along this line at the bottom, right? Fats are extremely important for hormone production. They're important for supporting cell growth. They're important for protecting organs. Monounsaturated fatty acids also activate one of the sirtuin enzymes. It's a very, very important longevity enzyme. It's called SIRT1. So eliminating fats is a terrible idea. It's going to make you very unhealthy, and definitely don't get too close to that line at the bottom. So at the next extreme, let's say you were an Atkins 1.0 fan and you believe that all you really need is protein, right? 9 of the 20 amino acids that your body absolutely needs to survive can only come from your diet. Oh, I'm sorry. We're actually looking at the opposite extreme where you were trying to minimize protein. And there are certainly some out there who will say, try and minimize protein. There certainly are benefits to short-term amino acid restriction. But your body needs protein. Again, 9 of the 20 amino acids have to come from your diet. Several others your body has a very hard time making on its own. It's especially true if you're doing resistance training, right? If you're trying to add muscle, and honestly, everybody should be doing that, you need protein for that. So eliminating proteins is a terrible idea. So let's say we went to the other extreme, right? So anywhere along this line to the right, fats to protein. If you try and eliminate carbs entirely, that's also a bad idea. Now, technically, your body can survive without carbohydrates. Eskimos tend to have a very low carb diet, right? Not a lot of plants growing in Greenland. But if you eliminate carbs, you also eliminate vegetables from your diets, you eliminate fruits from your diets. Those tend to reduce cancer risk, they reduce all-cause mortality, they feed your gut microbiome, they have a lot of other pro-longevity benefits. Also, some people are genetically predisposed to lose more weight with a higher index of complex carbohydrates. It's not true of everyone, but there are certain genes that correlates with. So, just to summarize, we've got different body compositions, different lifestyles, different fitness regimens, different gut microbiomes. Some of us have special food allergies and sensitivities. Some of us have leaky gut syndromes. And most importantly, we've got different genetic responses to various macronutrients and micronutrients. So there really is no one-size-fits-all diet. And you definitely want to avoid the extremes of saying certain macronutrients are good, certain macronutrients are evil, because that's really never the case. It is strongly influenced by genetics. I'm not going to read all the individual genes on this slide, but I thought I would just put this here to give you a sense of how many genes are involved in processing carbohydrates, fiber, total fats, saturated fats, etc. If you analyze your DNA, you can find out which of these genes you have and what your responses to some of these are going to be and how that actually should impact your diet. Also a lot more for plant sterols, protein, gluten, dairy sensitivity, and so on. Just a couple of universals. Again, going over this really quickly. Try not to diet. Try to make permanent eating changes that are sustainable, that you can stick with forever, for the rest of your life. Eat strategically and not based on stress or emotion. Try to give your body what it needs when it needs it. Maximize food quality as much as you can and avoid ultra-processed food. Try to get most of your carbs from plants if possible, especially leafy green vegetables. Minimize sugar and refined carbs that are going to spike your insulin. Try and eat healthy fats, especially saturated fats and monounsaturated fatty acids, including fish oil and olive oil, which are incredibly healthy for you. Also get high quality protein and enough of the essential amino acids, but you don't want to overdo it. There is some merit to the argument that getting too much protein will actually shorten your lifespan. As a general rule, when it comes to eating, if your great-grandparents wouldn't instantly recognize it as food, don't eat it. That is a great takeaway. Here's an article from Dr. Robert Lustig saying, processed food, an experiment that failed. Most of the new food types that were invented in the last century are extremely unhealthy. They're full of vegetable oils that don't do us a lot of favors. They have a ton of high fructose corn syrup in them that spike your insulin, and that's definitely going to shorten your lifespan. So let's talk about supplements and micronutrients. Really interesting chart on the left. This is the percentage of the US population not meeting the recommended daily allowance. Starting from the bottom, vitamin E, 86%. Folate, 75%. Calcium, 73%. I'll skip to the chart on the right. This is really interesting. This is the percentage of the US population obtaining less than the adequate intake for selected nutrients from food alone. Food alone is the red bars. And then from food plus a multivitamin supplement. So the red folks are trying to get enough micronutrients just from food. The green bars are also taking a daily multivitamin. And so this chart is comparing those two. Right here, sorry, it's really small, you can barely read it, but this is potassium. You'll notice both bars are 100%. Literally nobody is getting enough potassium. Vitamin D. It is something like, 90% for the food-only group and 70-some% for food-only plus a multivitamin. Choline, both are in the 80s. So essentially, all of us are not getting adequate micronutrients. And why is that? There's a lot of reasons for that. One is that the standard American diet is full of artificial food with little nutritional value, right? It's processed food. There are very, very few micronutrients in them. Soils are depleted, so even if you go vegan, even if you try and eat naturally, even if you eat paleo, you're not going to be able to get adequate levels of most micronutrients. Also, most of the multivitamins out there are pretty terrible. They don't have adequate levels of most of the micronutrients you need. They've got the wrong forms of a lot of micronutrients, and a lot of them have very poor absorption. They go in one end, they go out the other end, and less than 10% of a lot of these actually get absorbed. So they're really not doing you any favors for the most part. There are a couple of reasonably good ones, but just taking a multivitamin is not doing as much for you as you probably think. Also, the recommended daily allowance itself is very far from optimal, right? It is trying to be this general number for the entire population, and of course you cannot do a single number that works for the entire population. And in most cases, like, okay, it's enough of an intake of vitamin C so that you won't get scurvy, right? Well, you kind of want more than that, right? So many RDA values for many micronutrients are far below the optimum level, and in some cases they're actually too high, right? Many people, including me, have genetic variants that say we should not take a vitamin E supplement because it's going to increase our levels of inflammation, and we should only be getting vitamin E from food, right? Men generally should not supplement with iron. Taking a multivitamin with iron in it is a bad idea. That's why we have men's multivitamins that don't have any iron in it. So you've got to be really, really careful with this. So the optimal for the average person will not be optimal for you. And your ability to absorb, retain, and metabolize different micronutrients can vary enormously depending on your genetics. One thing to note is forget the idea of natural, right? Your body doesn't care where a particular chemical comes from. Once it gets inside the body, it doesn't care whether you ate it in a vitamin supplement, in food, if you breathed it in through the air, whatever. Once it gets into your system, it's going to behave based on what that chemical is and the chemical composition and the chemical shape, right? So don't worry that taking vitamins is not natural. Really, the goal should be to give your body what it needs. And again, just to briefly make the point, not going to go into these individual genes, but everybody has different single nucleotide polymorphisms for each of these different genes. You can see there's almost a dozen there for vitamin B12 alone that determine how much vitamin B12 you should be taking and which form of vitamin B12 you should be taking. Same thing with B6, vitamin A, selenium, magnesium, you name it. So everybody is different. Okay, so that's it for micronutrients. Fitness. Really interesting quote. I'll post a link to the study in the show notes. Men and women in the highest tertile of overall physical activity. In other words, they took men and women and divided them into 4 different groups depending on how much exercise they did. And the ones in the highest exercise group had on average a 77% and 92% lower risk of mortality than their less active counterparts. That's huge. So people who did the most physical fitness, if they were male, they had 77% lower risk of dying for any reason in any given year, and women had a 92% lower risk of dying from any reason. Here too, genetics makes a huge difference. Different polymorphisms influence your muscle fatigue, your recovery, your strength and hypertrophy. That's how large your muscles can get. Your endurance, soft tissue risk, VO2 max, which is tied to your lung capacity with exercise. So this too is very individualized. There's no single fitness routine that's going to work for everybody. But fitness is important. You've got to do it in some form. All right, the next subtopic we're going to discuss is minimizing all-cause mortality risk. Now, you may be looking at that and saying, okay, you talked about health span and lifespan, right? This is not going to increase my lifespan. This is not going to make, if I'm going to die at 85, then reducing my risk of dying any given year, I'm still going to die at 85, right? I just increase my chances of getting there. And that's true, okay? Technically, this is not going to make you live to 150. The things in this category are just to reduce your risk of dying in any given year. But two things to think about with this. One is the longer you want to live, the more you need to put the odds in your favor, right? If any given year you have a certain chance of dying from a given reason, and you're gonna live to be 80 years old, now some anti-aging drugs come out that'll extend your life to 160. Now you're rolling the dice twice as many times. And second thing to consider is this will actually increase your odds of living long enough to take advantage of those. So in order to explain the stuff in this section and why they work, we have to briefly talk about the concept of hormesis, right? The idea of hormesis is really pretty simple. It's that small amounts of a bad thing sometimes can be a good thing. And the reason is they provoke a fundamental response in your body, and that positive response from your body is stronger than the damage that you did to it, right? So you've sort of got this curve where on the horizontal axis, you've got the dose of the stressor, and then the vertical axis is the effect where higher is better. So you do a little bit of something and you get some hormesis and your body responds positively and said, okay, you stressed me out a little bit, but man, that made me stronger. But then you did too much of it and now you went downhill. It's important to understand there are different types of hormesis. It's not a single thing, right? Your body does not have one single hormetic response. It has many of them. And you want to activate as many of them as you can. So in this image are three different things we're going to talk about that reduce your all-cause mortality risk. And they'll do it by provoking different forms of hormesis. Top right, sunlight. How does sunlight work? What are the benefits from? Well, it certainly increases the levels of vitamin D in your skin. It increases the level of nitric oxide in your skin. Probably does some other stuff that we don't know exactly, right? But that's how that works. Also, you're outside, you're getting fresh air, you're taking a stroll, working your leg muscles. So all those are various types of hormesis. Sauna, heat stress. That is putting your cells, all the cells in your body, under the stress of heat, and they generate special heat shock proteins to compensate for that. And heat stress and the generation of heat shock proteins is strongly associated with longevity in not just in humans, but every species that's been investigated. Exercise, lower left, right? You exercise, you increase your heart rate, you train your heart, you build up lactic acid in your muscles, that has a positive response. Also, it acts as a senolytic. We'll talk about what that does later. But again, the point is, three totally different types of hormesis, more than three. It's also important to recognize not everything provokes hormesis, right? If you were to ask me, okay, Paul, how many cigarettes should I smoke to get the best hormetic response? And the answer is 0, right? Don't smoke, because any amount of smoking is correlated with a negative response, right? Any amount of smoking is going to proportionally increase your risk of getting lung cancer, right? Pulling all-nighters, you don't ever want to do that. It causes permanent negative changes to your brain. Sticking a fork in your eye, you get the point. Sauna. Sauna is one of my favorite ones. There was an amazing study done in Finland a couple years back where they looked at 3 different groups of men over the age of 50, and they classified them into 3 different groups. There were the men who did sauna once a week, the men who did sauna 2 or 3 times a week, and the men who did a lot of sauna, they did it 4 to 7 times a week. And it's really interesting, they found the men who did it 4 to 7 times a week had a 40% lower all-cause mortality risk. So they had a 40% lower risk of dying for any reason than the men who only did it once a week, which is amazing when you think about it. And really this study only looked at the once a week compared to the 4 to 7 times a week. So there really was no control group that didn't do any sauna. So the effect of sauna is probably even bigger than this. Also a 50% lower cardiovascular risk in that group that did the most sauna. Also a 65% lower risk of Alzheimer's and dementia, which is amazing. And again, part of that is, at least a big part of what's going on there is sauna is inducing heat shock proteins in all your cells that have very, very powerful longevity effects. It also boosts your levels of IGF-1, it boosts your levels of growth hormone, it also acts as an exercise mimetic because it gets your pulse going. If I sit in a sauna for 20 minutes, my pulse gets up to 150 beats a minute, and that's serious exercise at that point. I'm really giving my heart a workout by just sitting in the sauna. There's also infrared sauna, right, which tries to give you the same benefits of sauna. You're sitting in a room with infrared lights that'll essentially heat up your skin. And people ask me, okay, does this work? And the answer is yes, sort of. When I do infrared sauna, usually it takes me a good 50% longer to work up the same kind of sweat and get the same kind of benefits. And so I personally tend to avoid infrared sauna. I don't use it unless it's the option of last resort. It does seem to have a benefit. There are some studies that have found that infrared sauna will actually, the infrared light will actually penetrate into your skin and make you sweat out more toxins. And sweating out toxins is definitely one of the benefits of sauna, especially things like heavy metals. Infrared sauna is apparently better at that. I'm not totally convinced at that, but I find it interesting. Also, there's steam rooms and hot yoga. Hot yoga is essentially doing yoga at a room that's 120 degrees, kind of like Texas summer. Those may have benefits, but I personally am very, very skeptical that those are going to give you anywhere near the benefits of an actual Finnish sauna because the temperatures are so much lower. Resistance training, weightlifting. There was a study that found resistance training had a 21% lower all-cause mortality risk when done by itself, and a 40% lower all-cause mortality risk when combined with aerobic training. Now, again, this is a case where there seems to be a hormetic curve involved. There's hormesis going on here. So there's a certain amount of resistance training that's good for you, but it also seems like it's possible to overdo it, right? There seem to be risks at doing it more than 150 minutes a week. So that may be the point where the hormesis curve actually tops out, and you get to that top of that green part and it starts going downhill again. But one of the interesting things is when it comes to longevity, gaining strength and lean body mass for most people is actually more important for longevity than losing fat, right? So if you're going to the gym, make sure you don't just focus on cardio, focus on resistance training, focus on getting stronger, because if what you care about is living as long as you can, and that's definitely my priority, then weightlifting is going to do you a lot of favors. Heavy cardio. There was a very interesting study that came out recently that found that running once a week was correlated with a 27% reduction in all-cause mortality risk. That's pretty huge. I tend to believe that this applies to any kind of cardio, not just running. And there's no additional benefit from more than one time a week. One key lesson from this, as well as from many other studies on fitness for longevity, is you really want to focus on intensity. Get your heart rate up to the max, get your breathing up to the maximum level, push yourself as hard as you can. Don't try and just... When I was younger, I used to get into the habit of just getting on the treadmill and just thinking in terms of calories in, calories out, because I was still thinking that exercise was the way to burn fat, right? And so I would get on the treadmill and I would do a lot of lazy cardio. And I would go, okay, I'm just kind of walking here, but I'm doing it for 2 hours straight, and it says I burned 1,800 calories, so that's a good thing, right? But I didn't get better. I didn't improve, right? I was not making my heart any stronger. I was just doing empty calorie burning, and that time would have been much, much better spent actually pushing myself just for 10 or 15 minutes, just once a week, and actually getting my body to the point where I provoke that response from maxing out the intensity. Intensity is what matters, right? People talk about step counting, a lot of people walk around with a Fitbit and say, oh, I burned this number of steps this week. That's not a good way to look at it, especially if you care about longevity, right? Because then you're just looking at, I'm doing this, rote, low level, low intensity calorie burning that's not, compared to what you could be doing with that time, either sitting in a sauna, lifting weights, or doing high intensity cardio. Just step counting is not a great use of your time. Coffee, this is interesting. Study found that there was a 15% reduction in all-cause mortality in people who drank 3.5 cups of coffee a day. And there was no additional benefit beyond 3.5 cups. Coffee even seems to reduce damage, dark coffee especially, seems to reduce DNA damage by roughly 23%. And there's some studies showing that caffeinated coffee is slightly better for you than decaf. But again, your DNA will influence your ability to metabolize just about anything. This goes for coffee as well. Not everybody can tolerate caffeine, not everybody can tolerate coffee, right? Some people actually have a higher cardiovascular risk if they drink coffee. So it's one of those things where it's not universal. Not everybody should actually be drinking coffee. And not everybody is a good caffeine metabolizer. Green tea. There was a very interesting pooled analysis of 8 studies. Again, I'll link to this, just like everything else, in the show notes, that showed that people who drank 5 or more cups of green tea a day reduced their all-cause mortality by 10% if they were a man, and 18% if they were a woman. So that's pretty amazing. Green tea is about a lot more than caffeine. There are a ton of amazing polyphenols in green tea, especially a chemical called epigallocatechin 3 gallate, or EGCG. When people talk about cancer and minimizing cancer risk, they often talk about EGCG. It also seems to help with weight loss. A lot of dietary supplements have it. But there's a lot of other stuff in green tea that seems to be super useful. Okay, alcohol. So I debated whether to actually add this slide, right? Because this one's a little tricky. The curve that you see here is several, each of these 5 curves is a different study that correlates alcohol consumption with all-cause mortality risk. So here's what's really interesting. 0 drinks per day is 1.0. 1 drink per day is associated with about a 16% average reduced all-cause mortality. And then as it goes up to 4, 5, 6 drinks a day, it cancels out that effect. Now, I want to make very clear, I am not making the claim that drinking alcohol will reduce your all-cause mortality. We can't quite make that inference. It's a case of correlation versus causation. Alcohol is a toxin, right? It's certainly a potent neurotoxin. We all know what happens when you drink too much of it. And this may not be causal. It may just be due to the fact that people who drink also tend to drink in social settings, and probably that socialization and talking to your friends has a lot of positive longevity benefits, and that's probably true, and that may be where this effect comes from, right? So I don't want to make the claim that you should start drinking, if you're not drinking, to reduce your all-cause mortality risk. But I personally find this very interesting. The optimally reduced all-cause mortality seems to be somewhere between 1/2 and 2/3 of a standard drink per day, every single day. One standard drink being a glass of wine or a beer or a shot of whiskey, right? So it's about 1/2 of that. But again, it's up to you to decide whether you believe this correlation actually is proof of any kind of causation and how much alcohol. But I do want to make the point that you should not use this as a justification for drinking more than 1/2 a drink per day. Because if you drink more than that, you're already past the point of actually getting benefits. If you can actually feel yourself getting buzzed on alcohol, you're already at a point where you're provably past that optimum curve, right? It's interesting that this looks just like that hormesis curve that I showed you a few slides ago, only flipped upside down, right? Where this is the maximum all-cause mortality reduction benefit. And you wonder, well, how could alcohol actually produce these effects? If it is, again, not saying it's necessarily a cause and effect relationship, but if it is, how could it produce those effects? And it's interesting, it does actually seem to downregulate something called mTOR, which we'll talk about later. Could also be, helping your body detoxify, killing microbes in your system and reducing your body's microbial burden. Sunlight is also correlated with reduced all-cause mortality risk, up to a 50% lower all-cause mortality risk. We really don't know why this is. We don't know whether it's due to vitamin D, whether it's due to nitric oxide production, cytochrome C oxidase in your mitochondria, or if it's just walking, socializing, getting some fresh air, or if it's all of those. But it is very, very interesting that the reduction in all-cause mortality seems to be so powerful. Also, giving blood. There's a very interesting study that found that every annual donation of blood reduced all-cause mortality risk by about 7.5%. There's a quote here at the bottom, "This cannot be interpreted as conclusive evidence of a beneficial health effect." So again, this may not be a case of correlation actually being causation. It may not be cause and effect. But for my part, I found that I've done some blood tests. I found that I have a little bit too much of certain heavy metals in my system, a little bit too much mercury. I'm trying to get rid of those. So I'm now making a point of giving blood as often as I possibly can because I want to get my levels down. Every time you give blood, that's about 10% of your total blood supply leaving your system. So that's going to reduce your blood levels of those toxins by about 10%. And that may be where the benefit comes from. Okay, optimize key biomarkers. So there's a really, speaking of blood testing, there's a really interesting website, aging.ai. You just type aging.ai into your browser. And if you have a copy of your latest blood test from your doctor, you can basically just type in your blood biomarkers, your HDL cholesterol, your LDL level, your fasting blood glucose, your albumin, all the stuff that it shows you on that chart. Especially the 3.0 model, if you go to aging.ai, only requires 19 different blood biomarkers. And what that'll do is it'll actually guess your age based on your blood. And that's really, really fascinating. And the correlation is pretty strong. And I like this a lot because when you get the results of your blood test back from your doctor, you're going to get a reference range for each of these different things in your blood, your HDL, your LDL, and it's this huge range. And the range is so broad, it's almost meaningless, right? That's not really going to tell you what the optimal level is. It's not going to tell you, here's the value you should actually be targeting. My dad, I asked him for his blood biomarkers a couple of months ago. I typed in his numbers. He had a blood glucose of about 105, and his doctor didn't even warn him about it, right? I found that a little shocking because the reference range itself only goes up to about 100. If you're 105, that's, probably a little higher than it should be. And so then I was able to type that into the aging.ai and say, okay, Dad, you're 78, and it says you're 68, which is pretty good, but look what happens if you got your blood glucose down to 85, something like that. Suddenly it says you're a 30-year-old. So see what kind of effect you would have from actually lowering your insulin, lowering your blood glucose. It's pretty powerful stuff. So it gives you, many of these blood biomarkers are really, really easy to target and improve over time if you know how to do them. Now, I have to make a disclaimer because that's not actually true for everything on here. There are some things that change over time and you want them to change over time. HDL cholesterol is a perfect example. When we're young, our HDL cholesterol tends to be pretty low. As we get older, it goes up. The reason it goes up is HDL is good for you. It's positive. It's a protective mechanism in your body. And as we get older, our body is producing more of it. And higher levels of HDL cholesterol, as opposed to LDL, which is commonly referred to as the bad cholesterol, higher levels of HDL are strongly associated with improved all-cause mortality risk, right? So you really want your HDL to be high. So if you were to take a naive approach to this and say, oh, I'm just going to try and target everything to the blood biomarkers of a 20-year-old, you could be making a mistake in some cases, especially with things like HDL, where you want to say, hey, my HDL getting higher over time is actually really good because that's my body repairing a lot of the damage that's going on. Epigenetic aging clocks. We talked about epigenetics earlier in the talk, the little methyl groups that get attached to your DNA. It's essentially the software that's running on top of the hardware of your DNA. What's really interesting is that scientists have been able to develop specialized aging clocks based on your epigenome. In other words, they can scan your DNA, look at which methyl groups are attached to which genes, which parts of your genome. Based on that, they can come up with an extremely good estimate of your biological age. There's one called the Horvath clock, invented by Steve Horvath. You can Google that. There's another one called GrimAge. There's several others. There are various companies that offer epigenetic aging clocks, such as MyDNAge, and about a 96% accuracy. Now, what's cool about this is that now we can look at this and say, this is even more accurate than the blood biomarkers that we were just looking at. This is looking at your epigenetics. So this is extremely accurate, and this will give us a way to say, okay, I've created a new pill. I've created a new supplement, whatever, a new fitness routine. I want to see how that actually impacts your age. But again, if grandma is 70 years old, we can't afford to wait until she's 120 years old. We need a faster way to do this, a faster way to find out if what we're doing is actually working. And that's where epigenetic aging clocks come in, because they can tell you very, very quickly, okay, this person's epigenetic age changed in such and such a way. And I'll give you an example. You can hardly see this chart on the right because it's really small and fuzzy, and I apologize for that. But I'm going to call some of these out because they're really interesting. So this chart, what it does is this shows how a lot of different things impact your epigenetic age. This is a big study on thousands of people. And these are essentially correlation values. So like exercise, sorry it's so small you can barely see it, but exercise has a negative 1.0 correlation, and that's good. Negative in this case is good because it means it's correlated with a younger age. So people who exercised more had lower epigenetic ages, and the epigenetic clock for those people thought they were a little bit younger. So that's great. Income, same thing, seemed to be younger. Education, same thing, seemed to be younger. Waist to hip ratio and body mass index, positive, right? The more weight you're carrying around your midsection, the higher that epigenetic age is going to be. Some of the blood biomarkers are in here as well. C-reactive protein, insulin, glucose, triglycerides all have really strong positive correlations, which again is a bad thing. So you really want to try and minimize these as much as possible. At the same time, there's some interesting things like lycopene, alpha-carotene, beta-carotene, all the stuff you find in carrots that are associated with a significantly reduced epigenetic age, which is awesome. So blue is good, red is bad. This is really interesting. Doctors tend to freak out about LDL cholesterol, right? Your LDL cholesterol is too high, that's a scary thing, we better put you on statin drugs, right? I don't want to get off into the woods on talking about cholesterol. Again, they call HDL cholesterol the bad cholesterol, but you'll notice the score here is 0. If LDL is such a huge problem that we need to be putting half the country on statin drugs, you got to wonder, why does this not show up in the epigenetic age biomarkers? It's 0, right? There are a dozen things in this list, at least, that seem to be more important than LDL cholesterol. So just wanted to throw that out there. Telomeres are another thing you may hear about a lot in the news. Your DNA has little strands, your chromosomes have these little tips on the end. They're like little shoelace tips. They're called telomeres. When you're born, they're really long. Every time your cells divide, they get a little bit shorter, right? And by the time you are, 70 years old, they're maybe a tenth of the length that they were when you were born. And that is one of the reasons that we see so much decline so suddenly in old age is because it's like a little fuse that's burning down. And as that telomere gets to the end, that triggers a cellular program where the cell is now going to try and commit suicide. It's going to remove itself from the body, and it may not even succeed. It may just stay there and become what's called a senescent cell. We'll go over that later. But telomeres are super, super important for aging. And one thing that's interesting, also I should mention, telomeres aren't just shortened by cell division, they're shortened by a number of other things, especially stress, right? If you are stressed out, if you're not getting enough sleep, if you're not getting enough exercise, if your diet is terrible, your telomeres are actually going to get shorter even faster, right? It's going to accelerate the rate of telomere shortening. And what's really interesting is we can actually extend the telomeres of mice. Some humans have tried this therapy as well using a virus, right? Implant a virus into the mouse or into the person to actually grow the telomeres, and at least what we've seen in mice is those mice live a hell of a lot longer. I'll talk about that a little more later. But anyway, this is another case where you can actually test the length of your own telomeres. I've gotten mine tested. A bunch of companies do this, teloyears, SpectraCell, life length, there's several others. HRV, heart rate variability. This is the heart's ability to accelerate and decelerate on demand. This has gotten extremely popular in the fitness community. And this is very strongly correlated with age as well. So you'll notice it tends to go down over time until the age of about 70, 75, 65, where it tends to gradually go up for most people. And generally speaking, you want this to be as high as possible. So if you use a sleep tracking device like an Oura Ring, that'll tell you your heart rate variability at night. And generally having a better state of cardiovascular health is going to improve your heart rate variability. Resting heart rate is another really important one. What is your heart doing when you're just sitting around doing nothing? What's it doing when you're sleeping? A resting heart rate of around 40 beats a minute has the strongest correlation with minimized all-cause mortality risk, 40. Right? Most doctors will try and get you maybe into the 60s, and if it's in the 50s, they'll think something's wrong with you. But this is a case where lower is better. Having your body in better shape, having better cardiovascular fitness is strongly associated with the lowest all-cause mortality risk. Here's an interesting quote: every beat per minute increase boosts the risk of death by 3% during the next 11 years. A couple other biomarkers we're talking about. People often talk about weight and body mass index. I personally hate both of those. Weight is very misleading. We all say we're trying to lose weight. We're not actually trying to lose weight. We're trying to improve our body composition. We are trying to lose fat. And in many cases, we're also trying to add muscle, but we're trying to get our fat percentage down to an optimal level. For my part, when I look at my weight, it stresses me out because I drink a ton of water, and then I also sweat out a ton of water because I do so much sauna. And so my water weight can vary by as much as 7 pounds from one day to the next. And I didn't actually, add 7 pounds. I just drank 2 gallons of water, starting in a dehydrated state, right? BMI is also very deceptive because it doesn't just look at fat, it also looks at muscle mass, and having more muscle mass is very, very, very good for you. It's much more important in most cases than having a smaller amount of fat. So instead of looking at weight and BMI, consider looking at your body fat percentage. The optimal body fat percentage, generally speaking, we can also look at lean body mass index. This calculation, you basically take your weight, you subtract the amount that is fat. There's special scales at many gyms, DEXA scanners, things like that, in-body machines that can tell you your body fat mass or your body fat percentage. Anyway, you take your weight, subtract the fat mass, divide by your height, meters squared, and you just want that to be as high as possible. Try and get it above 20 if you're a man, above 17.5 if you're female. Some additional biomarkers worth looking at: push-up test. If you can do more than 40 push-ups, that's associated with a 90% lower risk of a cardiovascular event. What's your deep sleep percentage? When we're young, 20 years old, that tends to be about 18% of sleep. It goes down to around 11% at age 78. I wear an Oura ring to track my sleep every night, and I'm always trying to get my deep sleep as high as I can get it. Glycation, that's whether the proteins and sugars are sticking together inside your cells. There are various devices that can measure that. Phase angle, which is essentially a measure of cellular health. There are specialized scanners that can look at that. There are various cognitive scanners such as age meter that do, reaction time, hearing tests, and so on. Also blood pressure. And ideally, you want to look at as many biomarkers as possible and combine them. So here are my actual scores. You can see my chronological age is 47. My age meter cognitive test says I'm 41. My phase angle from a Seika scanner says I'm 29 years old. And then my blood biomarkers from that aging.ai website say that I'm 28. So that's all great. Unfortunately, I also got my epigenetic clock looked at through my DNAge, and I did a telomere length test, and both of those say I'm 48. So that kind of tells me where I'm at. There are certain areas where I seem to be doing really well, and certain areas, such as my epigenetics and my telomeres, where I probably have a slightly larger risk. Okay, now we get to the heavy stuff. Repair the types of damage that cause aging. All right, guy in the lower left corner, I want to just call this out right away. This is Dr. Aubrey de Grey. He is the creator of the concept of SENS. This is his book, Ending Aging, the Rejuvenation Breakthroughs That Could Reverse Human Aging in Our Lifetime. Highly recommend this book. It's a great read. But this book takes you through the entire concept of SENS. SENS stands for Strategies for Engineered Negligible Senescence. I talked at the beginning of the talk about antique Model Ford cars that are still running 100 years later because they're continually repaired. And I talked about having a taxonomy of different types of damage that occur inside the human body so that we can have a way to focus our efforts and say, how do we tackle this type of damage? How do we tackle this other type of damage? How do we tackle this third type of damage, right? And if we repair the damage from aging well enough and frequently enough, then at some point, we'll effectively not be aging at all. That's the theory anyway. I don't think I'm doing it yet, but I'd like to be doing that someday. So this chart on the right is the classical SENS taxonomy of aging-related damage, and we'll go through each of these 9 in turn. The first one is genomic instability. So over time, your DNA accumulates damage, mutations in your DNA. Good news is this doesn't seem to be a real big risk. It's probably not a major near-term cause of aging, and it has now been proven to have minimal impact on lifespan in humans. So that's good, right? By the time your DNA gets damaged enough to actually cause problems for a particular cell, that cell is probably going to go ahead and detect the damage and remove it itself if it finds that it's not able to repair the damage. Having said that, there are a lot of things you can do to mitigate this problem. Drink dark coffee, as we discussed, it seems to reduce DNA damage roughly 23%. Selenium, having adequate levels of selenium, you can get that from fish, is very important for DNA repair. Also a number of spices and supplements, curcumin, pterostilbene, a drug like metformin, a couple peptides, copper tripeptide 1, I won't go through the list. Anyway, most of these we'll only be covering in one slide due to time constraints. For each one of these, I'm going to talk about a couple basic strategies to mitigate that type of damage and also just briefly mention some of the research that's going on in that area. But I'll link you to a website that'll also be in the show notes where you can dig into more details on the ongoing research. We talked about telomeres, the little caps at the ends of your chromosome that are like little fuses that get shorter every year, every time your cell divides, and especially when you're stressed out and not taking care of yourself. There's a really good book called The Telomere Effect that talks about some of the ways that you can slow the rate of your telomere shrinkage. It goes into a lot of detail about managing stress, meditation. Meditation actually reduces the rate of telomere shortening, which is amazing. Detox, exercise, getting enough sleep at night. There are also some supplements that seem to help maybe with at least reducing the rate of telomere shortening, if not lengthening them. There's TA65, TAM818, and epidolon. I'm personally skeptical about all three of these for various different reasons. There's also L-carnosine, which is a very important nutrient. It's actually found in red meat, but it seems to be very effective at reducing telomere shortening. There's also some very interesting research going on here. There is 2 companies, at least, that are doing work into actually lengthening telomeres. There's BioViva Science and Libella Therapeutics. I think BioViva, the cost, these are some of the ones that are fairly expensive. BioViva, I think, is around $350,000 for this therapy, and Libella is doing it for like $1 million, which is just crazy, right? But some people have actually gotten this therapy. They inject a virus. This virus goes into your cells, or at least about 60% of your cells, and then inserts, some DNA that activates telomerase that then extends your telomeres and makes them longer. So that's great, and it seems to work. I've seen some pictures of mice that have gotten this therapy, and it's really amazing. You see, on the one hand, here are some mice that are the mouse equivalent of 70 years old, and they look old and gray, and they're just falling apart. And then here's another group of mice that's the exact same chronological age. They were born at exactly the same time. They look half their age because they have longer telomeres. So telomere lengthening therapy really does work. It's incredible, or at least it really does work in mice. Hopefully someday soon, within the next 15 to 25 years, it'll actually be affordable. Epigenetic alterations. So we talked about epigenetics earlier, the little methyl groups that attach to your DNA. Again, everything you do in life, pretty much, is going to affect your epigenetic expression of your DNA. Your fitness, your sleep, your diet, your supplements, how stressed out you are, and so on. And this could be the most important out of all the various factors of SENS. We now have the ability to actually reset a cell's epigenetic expression to actually make it younger. And the hard part is actually getting it to revert to the point where it's just young enough, right? You want to say, okay, I'm 47 years old. I want my cell to reverse itself to think I was 20 years old again, but not go so far that it becomes a stem cell and just loses its identity again. But we're really close. We seem to be really close to solving that problem. There's a lot of very interesting research going on at the Salk Institute. There are a lot of peptides that are being developed. So in terms of lifestyle, there's a lot you can do with diet, with resistance training, meditation, sleep optimization, exactly the same stuff as for lengthening your telomeres. Supplements, extra virgin olive oil. Olive oil actually has a significant impact on your epigenetic expression. It's amazing. Vitamin D, whether it's from sunlight or through a pill. Omega-3 fish oils like EPA and DHA. There's a couple others. Loss of proteostasis. So essentially what this means is inside every cell, it accumulates a lot of junk, especially proteins that have been folded the wrong way or that are just no longer being used. And they got to try and clear out that junk. And one of the things that can go wrong as we get older is they stop being able to take the trash out. Maybe there's so much trash that they just can't take it all out anymore. Maybe that trash gets stuck together, right? Like advanced glycation end products where you have sugars and proteins that are stuck together in this bond that we currently don't know how to break, right? So there's a lot of research going on in this area. Glycosens, Lysoclear, some of the ones listed down at the bottom, cyclodextrins, a lot of other stuff. But in the meantime, until more advanced therapies are available, there is actually a lot you can do. One of them is increasing autophagy. That is the cellular cleanup process that happens inside your own cells. That includes fasting and time-restricted eating, which I'll talk about later in the talk. Aged cheeses actually have a compound called spermidine, which increases the amount of autophagy in your cells. It's amazing. They've found that if they give mice aged cheddar, they live 25% longer, right? Just because of eating this aged cheese that has these special polyamines in them. Heat shock proteins in sauna. Heat shock proteins do an amazing job. Essentially, the role of the heat shock protein is to go around, find other misfolded proteins, and try and get them into the correct shape or tag them for removal if they can't do that. There are also some supplements that help with glycation. I mentioned carnosine on the last slide, which is found in red meat. You can also buy it as a supplement. And that helps prevent or mitigate sugars and proteins sticking together inside your cells. A lot of others like caffeic acid, which is found in coffee, a bunch of other supplements, benfotiamine, pyridoxamine, EGCG from green tea. Okay, deregulated nutrient sensing. I have to do a little bit of a deep dive on this one because it's pretty important, and there are three major pathways here. When we talk about deregulated nutrient sensing, we're talking about your body becomes less able to properly deal with the nutrients that you're putting into your system. I guess that's the best way to describe it. But we're going to talk about the mTOR and AMPK pathways. We're going to talk about sirtuins, and we're going to talk about the IGF-1 and insulin pathways, all of which are very important. Okay, so you might have seen this headline. This is an amazing headline. Scientists increase worms' lifespan by 500%. Worms don't live all that long, so you might think, okay, this isn't actually that much of an achievement, but still, 500% is a lot. That would be the human equivalent of around 500 years of additional lifespan. And one of the biggest ways that they did this was through the mTOR and AMPK pathways. Now, really briefly, mTOR and AMPK are two competing pathways. When one is upregulated, the other is downregulated, and vice versa. mTOR essentially is the one that gets upregulated when you eat, and it says, okay, I'm well fed, conditions are good, hey, let's add more cells. Let's have kids. It's the growth pathway. Let's add more. Everything's fine. The AMPK pathway is the survival pathway. It says, oh, I'm starving, okay? I might be in a famine, I don't know what's going on here, but I better make sure I devote all my resources to keeping my human in the best possible shape so that I get out of this and have babies, right? So one of the biggest problems we have right now in Western civilization is we've put this high fructose corn syrup in everything, spiked our insulin levels, and we eat 12 to 14 hours a day with snacks in between. We are upregulating AMPK all the damn time, and we very rarely activate AMPK, right? Now, I want to make very, very clear, I'm not demonizing mTOR. mTOR is also very important. You need it to be activated sometimes, right? It's an essential part of the human system, and especially if you're lifting weights, if you're trying to put on muscle mass, that's going to come from mTOR, right? That's growth. So I don't want to make it sound like this is a good versus evil dichotomy, but what I am saying is in Western civilization, we're kind of out of whack right now. We're so far over on the mTOR side, and there are a ton of benefits to be gained from being conscious of this and saying, hey, today is an mTOR day, but tomorrow I'm going to activate AMPK, or here's how I'm going to deal with AMPK, because AMPK has a ludicrous number of survival benefits. A lot of things you can do to upregulate AMPK: fasting and time-restricted eating. A lot of supplements like quercetin, berberine, alpha-ketoglutarate, hesperidin, all these you can buy, through the internet. Alcohol inhibits mTOR, which then almost certainly raises levels of AMPK. There are also a couple of drugs, very popular anti-aging drugs, such as rapamycin and metformin. I don't want to go into a lot of depth on either of those. I will say they both require prescription. They're both very powerful. They both have a lot of side effects. Rapamycin in particular is a very powerful immune system suppressant. So don't just go ordering those on the internet and using them, please, because there's a lot you need to know in terms of what the potential side effects of those are and the proper dosing of each of those. But I thought I should at least mention them in the AMPK section. Also, sirtuin genes. We have a number of genes strongly associated with cellular survival, the SIRT1 through SIRT7 genes. There are various compounds that can activate those. Resveratrol, which you may have heard of, very popular anti-aging supplement. Extra virgin olive oil has the same effect on sirtuins as resveratrol. Pterostilbene, fisetin, quercetin, again, all these you can order through the internet. One of the interesting things is these all require a chemical called NAD plus to function properly. And I want to take a little bit of a detour on the next couple slides and talk about NAD plus, because this is something that everybody in the longevity space is currently talking about, and almost everybody is supplementing with either NAD plus or some form of NAD plus precursor, because NAD plus has been shown to, increasing NAD plus levels has been found to have significant life extension potential in many different species, including humans. So when we're young, we have a lot of NAD plus in our system. It's found in every cell. It's fundamental for energy metabolism. By the time we're 80 years old, we have a fraction of the NAD plus that we had when we were younger. Restoring youthful levels of NAD plus seems to significantly increase healthy lifespan in every species we've studied so far. So, can you just pop an NAD plus pill? It's not quite that simple, unfortunately. The science isn't exactly settled yet as to the best way to raise your cellular NAD levels. There are a lot of different approaches that I'll talk about in just this slide and the next one. I'll make this real quick. There is NR, nicotinamide riboside. In your body, that gets converted to NMN, which is nicotinamide mononucleotide, and then that gets converted to NAD+. Now, problem with NAD+, it's a big molecule. You can't just take it in a pill because it's not going to make it through your digestive system. It'll be broken apart 10 ways to Sunday by your gut bacteria, by the enzymes in your stomach. So everybody is currently supplementing with things like NR and NMN. So there are a lot of different kinds of precursors. Again, there's NMN, nicotinamide riboside, NR nicotinamide riboside, NMN nicotinamide mononucleotide. There's niacin, vitamin B3. It seems to raise NAD plus levels. There are also a few of these that I won't go into detail on there. There are also many different delivery methods, such as oral, sublingual, nasal spray, IV drip, and something called iontophoresis, which is basically you take a patch that uses electricity to transfer it through your skin. So there are a lot of promising animal studies. The jury is still out on what is the best way to supplement with in order to raise your cellular NAD levels. The ones that seem to work, as far as I can tell, based on the best research we have, you can get an IV drip of actual NAD+, right? They stick a needle in your arm. It takes about 6 hours, and they actually put NAD+ directly into your bloodstream. That seems to work pretty well. There's also sublingual NMN. You can buy these little tablets. You dissolve them under the tongue. I believe that works pretty well. And then there's also NAD+ iontophoresis, which is those patches on the skin that transfers the NAD+ electronically through the skin barrier. So hopefully within the next year or two, we'll have much more definitive results on here's how to optimize your levels of cellular NAD+. But at this point, we know without a question that it actually works, surprisingly well in terms of increasing healthy lifespan in every species that we've looked at so far. So that's pretty amazing. Insulin sensitivity, this one's really, really important. This is very strongly linked to longevity, and insulin resistance is strongly tied to many of the diseases of aging, including type 2 diabetes, as well as Alzheimer's disease, which is also often referred to as type 3 diabetes. A lot of things you can do to mitigate this. Exercise will make you more insulin sensitive, calorie restriction, fasting, various supplements, resveratrol, berberine, and so on. So I've talked about fasting in several of the recent slides. I just want to take a little bit of a dive into that. Fasting is a very, very effective anti-aging strategy. One of the few interventions that's been found to work in every single species that it's been tried on in terms of increasing lifespan is reducing your intake of calories. Now this is really, really hard to do, right? Calorie restriction for humans means if you're a man, 1,200 to 1,600 calories a day. If you're female, it's about 1,000 to 1,200 calories a day. That's really hard, right? And it's super hard to sustain that. You're going to be cold all the time. You're not going to have a lot of energy. It is going to have benefits, but it's a tough way to live. I'm not saying don't do it, but I'm also saying I don't personally do it, and it's a challenge. And I think you may be able to get many of the benefits of calorie restriction in some of the other ways that we've already talked about. There's also calorie restriction mimicking diets such as Prolon, where you do, I've never tried Prolon, but my understanding is you're essentially limiting amino acid intake for a couple of weeks. There's also, so fasting, any kind of fasting helps health, longevity, and weight loss. Different kinds of fasting include intermittent fasting, which is skipping meals, 24-hour fasting. You say, okay, noon today, going cold turkey, nothing but water and tea and coffee, and then I'll have breakfast at noon tomorrow, right? There's multi-day fasting, going 1 to 5 days with nothing but water, coffee, and tea. I've gone for up to 5 days. It can get pretty intense, but you feel a lot better afterwards. There's also time-restricted eating, which is limiting your eating to a small time window, such as maybe 3 to 10 hours a day. This one is a lot easier to stick to than calorie restriction because you're not actually limiting your total number of calories. You can eat the same number of calories you normally eat. You're just doing it in a smaller amount of time, right? So I'm personally doing this. I found this is very, very easy to do, very, very easy to stick to, especially compared to something like calorie restriction. So basically just take your normal diet and say, okay, today I'm gonna eat in a 10-hour window, right? I'm gonna start eating at 10 o'clock in the morning and I'm gonna stop at 8 o'clock at night. No calories outside that window. Once you get into the swing of doing that, you gradually reduce it and say, can I do it in 9 hours? Can I do it in 8 hours? Can I do it in 7 hours? Can I do it in 6 hours? Because all that time that you're not eating, right, your body is not only starting to burn your fat for calories, you're also upregulating that AMPK and getting the survival benefits, and you're also increasing the autophagy inside your cells, so they're clearing out a lot of that cellular junk. And this has major benefits even without changing your calorie intake. It's much easier to stick to. And as a side benefit, overeating and snacking become essentially impossible, right? I'm now at a 6-hour window, actually 5 now. So I have breakfast, I have lunch maybe an hour after that, then I have a workout, and then I have dinner, and I'm done by 4 p.m., right? And there's no time for snacks in between those, which is great. So just by default, I can't possibly eat more than my optimal calorie intake. Really good article that I will link to in the show notes, Effects of Intermittent Fasting on Health, Aging, and Disease. This looked at people doing intermittent fasting for 6 hours, 6 hours of eating followed by 18 hours of 0 calories. It improved metabolism, fat reduction, brain health, reduced the amount of inflammation, improved disease resistance, improved stress resilience, and most importantly, longevity. Okay, mitochondrial dysfunction. So mitochondria, they're the powerhouses of our cells. Every cell has a whole bunch of these tiny little, organisms inside it, essentially. They're like tiny little bacteria that produce all of our cellular energy. One of the biggest problems we face in aging is we run out of enough healthy mitochondria. Mitochondria have their own DNA. That DNA gets damaged. We also suffer in terms of the overall quantity of mitochondria in our cells. So lifting weights, resistance training, improves your mitochondrial quality and density enormously. It actually helps your body generate new mitochondria. Also various supplements. There's one called PQQ, there's acetyl L-carnitine, R-lipoic acid, different forms of coenzyme Q10. A lot of things out there that seem to be beneficial in terms of improving the health and improving mitochondrial biogenesis, making more mitochondria. There's also additional research going on, which I'll link to in the show notes. Cellular senescence. This one is really interesting. So a lot of our cells are designed to essentially detect when they become, dysfunctional and remove themselves from the body. They're supposed to flag the immune system and say, hey, I'm broken, I'm gone. Just clear me out of the system. And then they get cleared out by the immune system. 99% of the time that works great. But by the time we get to the age of 50, we start accumulating what are called senescent cells. And those are essentially cells that don't work anymore. They no longer are functional, and they sit around and produce these horrible inflammatory chemicals. And that creates essentially an inflammatory cascade, right? You've got a lot of nuclear factor kappa beta and other inflammatory chemicals coming out of these senescent cells. That damage in those inflammatory chemicals in turn can cause other cells to break down and become senescent themselves. So that becomes kind of a runaway spiral. And what's really interesting is we can actually, this is one of the areas where we've made a ton of progress, and we've already got really good ways to clear out senescent cells. Not much of a problem for anybody who's under the age of 50, but for those who are 50 and older, there's what's called the D plus Q combo, which is, there's dasatinib, which I believe is an anti-leukemia drug, plus quercetin, which is a supplement that you can buy on the internet. The combination of those two, given in a very specific dosage for a short time, is remarkably effective at reducing the number of senescent cells and clearing only the senescent cells out of your body. There's also fisetin, which is kind of similar to quercetin. You can also get it on the internet. There's a peptide called FOXO4-DRI. Also, there was an article that recently came out that found that resistance training acts as a senolytic for skeletal muscles. So if you lift weights, that is actually going to itself clear out a lot of the senescent cells from your skeletal muscles, which is amazing. Weightlifting, again, I can't say enough good things about it. And additional research going on there as well, which I'll link to in the show notes. Finally, stem cell exhaustion. We've got stem cells inside our bone marrow, all of us. As we get older, we start to run out of stem cells. I actually got my own stem cells in July of last year. I had a doctor inject a needle into my bone right here, draw out some stem cells, take them and send them up to a lab in Michigan where they were multiplied and put in a freezer. And then, this was a company called Forever Labs. And then this picture right here is my selfie. Sorry. So the good news is I've now got a whole bunch of my stem cells sitting somewhere up in a freezer in Michigan, and when I get into my 50s, 60s, 70s, now those same stem cells can get re-injected into my system. So that's pretty awesome. So this is an area where we've made a lot of progress, and a lot more progress is going on right now. Finally, altered intracellular communication, especially things like inflammation. Inflammation goes up as we get older. Omega-3 fatty acids, eat a lot of fish, that will help get inflammation levels down. Sauna, exercise, optimizing your sleep, CBD oil also seems to reduce inflammation. Nitric oxide levels seem to get lower as we get older. Exercise will help with this. There are some supplements that can boost nitric oxide. Sunlight and red light therapy also seem to help with nitric oxide production in the skin. Also BDNF, which is brain-derived neurotrophic factor. It's important for your brain. It's also super important for your muscle, and there are a number of ways to increase that. Okay, so the point I want to make with all this, besides giving you all these ideas for how to counteract these different types of cellular damage, is that we're actually making massive progress on all fronts, right? A lot of these that we already discussed are either partially or mostly solved, which is amazing. We are so much further than the general public really realizes with addressing the fundamental causes of aging. There's a link down here to, if you go to lifespan.io on the internet, that has a rejuvenation roadmap, and that gives you a list of all of the advanced research going on in each of these different categories, and all the stuff that I had to skip over in this talk. So finally, this is our last section. Okay, I'll make this quick. Do what works in experimental models. There have been 12 major longevity interventions discovered for mice that each increase mouse lifespan by at least 10%. Those include calorie restriction and intermittent fasting, which upregulates autophagy, improves insulin sensitivity, reduces fat levels, produces ketones. Metformin, which is a popular anti-aging drug. It improves insulin sensitivity, activates AMPK. telomere lengthening, and genetic modification. The TRIM trial. Now this is the really, really exciting one. This is the first trial that essentially proved that we can start to reverse aging in humans right now. This was a combination of 3 different drugs that was given to people over the span of about a year and a half, only about 10 people, so the sample size is pretty small, but it was a combination of human growth hormone, metformin, and DHEA, which is essentially a master hormone, but you can buy it at your local CVS or Walgreens. The combination of those 3 had a significant effect on the epigenetic aging biomarkers of every single participant. So what I'm showing you here, each of these charts is a different epigenetic aging clock. This is the Hannum clock, this is the pheno-age clock, this is, I'm not sure what that one is. But 3 different epigenetic clocks that looked at the epigenetic expression of all the participants. I mentioned earlier that those have, generally speaking, about a 96% accuracy in terms of tracking to actual age. And here's what they found. 18 months later, after the start of the study, their epigenetic age should have been a year and a half older. Instead, according to this epigenetic clock, it was a year younger. So that's effectively reversing aging by 2.5 years. And these other clocks are very similar. So all 3 epigenetic aging clocks for every single participant showed that they were 2.5 years younger, and their age was effectively reversed. Now, can we do this repeatedly? Can we keep giving them this combination a couple months every year, and will that keep reversing their epigenetic age and keep them, I don't know, under the age of 50 for another 100 years? I don't know. I hope it does. But this is really exciting in and of itself because it tells us that for the first time, we can pretty much prove that we can start to reverse aging. Okay, peptides, I won't go into a lot of detail on this stuff, but these are naturally occurring short protein chains that have enormous biological effects, have a lot of utility in a lot of areas of longevity and anti-aging. Hopefully we'll have a talk, someone has offered to give a great talk on peptides for this group later this year. Exosomes, wanted to cover that really quick. They're essentially these tiny vesicles that are full of specialized growth factors. So what's really, really interesting is, we talked about stem cells earlier. What they found is that the power of those stem cells seems to come from these special growth factors inside the stem cells, right? And taking those growth factors, wrapping them in these little membranes called exosomes, and then injecting those throughout the body seems to actually be more powerful than stem cell therapy. So that's pretty amazing. So that has pretty enormous potential. Okay, we're pretty much done. I just want to quickly go over some of the books that I recommend in this category. If you care about the state of longevity research and you want to know more about that, there are 2 really awesome books that I recommend. On the left, Ending Aging by Aubrey de Grey, that covers the whole SENS paradigm and the taxonomy of different types of damage. On the right is David Sinclair's book, Why We Age, Lifespan, Why We Age and Why We Don't Have to. Sinclair's book is kind of actually a subset of SENS. It really is just talking about the epigenetic stuff, because that really is so powerful and it seems to be the most important aspect of SENS. Few good books on building a longevity plan. P.D. Mangan's book, Stop the Clock. It's really short, but it's really good. All of his advice is terrific. The Kaufman Protocol in the middle, it only talks about supplements. This is the single best book I have read for building your own longevity supplement regimen. And Dr. Sandra Kaufman does a terrific book of explaining, here are the different factors involved in aging, here are the specific dietary supplements that seem to be the most powerful in terms of reversing those aspects of aging. Again, it's very limited because it's only talking about the supplements and you need to do a lot more than that, but it is the best book on that particular subject. The End of Alzheimer's by Dale Bredesen. Again, I mentioned him at the beginning of the talk. He was the one who had that metaphor of you got a roof with 36 holes in it and you need to patch all of them up to really fix the problem. This book really is specifically about Alzheimer's and cognitive decline, but the reason I included it in this list is because his protocol, the RECODE protocol, for actually stopping and even reversing cognitive decline, the first person who's actually been able to reverse Alzheimer's, it's actually very, very similar to a good anti-aging protocol. So I highly recommend that book. Finally, Eating for Longevity, Grain Brain by David Perlmutter is terrific. The Switch by James W. Clement and Wheat Belly by William Davis, all terrific. And that's it. Thank you. So everybody, I hope you'll keep in touch. Send me feedback. Let me know what you'd like to hear more about. If you'd like future deep dives on any of the particular topics in that talk, if you'd like to know more about any one of those areas, let me know and we can make it happen. I've got several exciting speakers lined up for later in the year, but I want to hear from you what you would like to see happen for this group. Thank you.